This is part 8 of the series Reasoning and Proof. In the last part, we looked at a theorem, the right angle congruence theorem, as our introduction into the idea of theorems, that is, statements that aren't necessarily intuitively true but can be proven true. And now we're going to continue on with a couple of more theorems. The first one is the congruent complements theorem. And the congruent complements theorem says if two angles are complementary to the same or congruent angles, then the two angles are congruent. So here, if we say that angle 1 is complementary to angle 3, remember complementary means they add up, two angles that add up to, whose measures add up to 90 degrees. So if I say angle 1 is complementary to angle 3, and angle 2 is complementary to angle 3, then these two angles have to be congruent. In other words, let's say that this is 50. This angle would have to be 40. And 40 plus 50 gives you 90. If this angle is constant at 50, then this angle would have to be 40 as well in order for this angle to be congruent to be complementary to that. And if this angle has the same measure as this, then those two angles are going to be congruent angles. So that's the nature of this. And this part here that says to the same or congruent angles, that means angle 2 could be complementary to some other angle, like angle 4 out here, if angle 4 was congruent to angle 3. And that's kind of obvious, because if angle 3 is congruent to angle 4 out here, then they would have the same measures as well. So that's the congruent complements theorem. So let's go ahead and, as another practice exercise, let's go ahead and work through this proof. It's always good. The more practice we get, the easier this stuff is going to be. So here's our given. Angle 1 is complementary to angle 3, and angle 2 is complementary to angle 3. And we're going to prove that angle 1 is congruent to angle 2. Now, we already kind of went through a plan for the proof when I described the theorem itself. Since we know that this is complementary to this, by the definition of complementary angles, this angle, the measure of this angle plus the measure of this equals 90 degrees. And since this is complementary to this, the measure of this angle plus the measure of this angle is 90 degrees. And you can see then there's probably going to be a substitution involved that allows me to substitute this angle for this angle, and that will show me that these two angles are the same. Now, you should be able to even see in here a pattern forming. We may be able to do something like a transitive property, because we have this complementary to this and this to this. So it looks like we're going to have something related to that involved. So as usual, let's go ahead and write down our given information, and I'm going to abbreviate this to make it simpler. So I've said angle 1 is complementary to angle 3, and angle 2 is complementary to angle 3. Now, what does that tell us? Well, if angle 1 is complementary to angle 3, then the measure of angle 1 plus the measure of angle 3 is 90 degrees. And the same thing is true for this. So that's what I'm going to write next, and that's the definition of complementary angles. So again, the definition drives the statement. So here we have measure of angle 1 plus the measure of angle 3 equals 90 degrees. The measure of angle 2 plus the measure of angle 3 is 90 degrees. Now, we have to look and see what this tells us. Well, we have two values that are equal, and they're on the same side of the equal sign. We look at this side, let's look at this as one entire unit. If I know that this equals 90 and this equals 90, don't I have if A equals B and B equals C, then A equals C? That's right, transitive property. Now, you've seen the transitive property in pretty much every proof we've done so far. So again, these patterns will start to form, and you'll see them recurring over and over, which makes them easier and easier to start identifying. So that's what I'm going to write. The transitive property tells me that this equals this. Now, you may have been tempted to think of the substitution property. to say, well, since this is the same as this, I'm going to substitute. And I would discourage that only from the standpoint that there's only one substitution property. There's only a substitution property of equality. There is no substitution property for congruence of anything. And so if you get used to using transitive and only use substitution when transitive doesn't exist or isn't useful, then you're in much better shape. So here we have measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. Where do I have to get to? I have to get to the measure of angle 1 on one side and the measure of angle 2 on the other side. Well, the thing that's missing is I have an extraneous angle 3 here. But since they're the same sign, can't I just subtract angle 3 from both sides and eliminate them? Well, that's right. That's exactly what I'm going to do. I'm subtracting angle 3 from both sides to eliminate the angle 3. So here's our statement. I'd like you to further notice that I didn't write in the little crutch statements underneath that said I subtracted the measure of angle 3 here and subtracted the measure of angle 3 there. And the reason I didn't do that is because, number one, if you actually did that, you would run out of reasons because it's the same reason for both. And number two, it's going to cloud and clutter your proof up, and it's going to make it much more difficult to read. At this level, you shouldn't need those little crutch statements. And the more you practice this basic algebra, the easier that's going to get. But avoid using those crutch statements, because if you do, you're going to have a problem getting your proofs correct. So we subtracted angle 3 from both sides, and the subtraction property of equality gave us this. Now we're almost to the final step. We have angle 1, the measure of angle 1 equals the measure of angle 2, and we have to get to angle 1 is congruent to angle 2. Do you remember the reason we could go from equality to congruence? That's a definition. The definition of congruent angles is if two angles have the same measure, then they are congruent. And the converse, if two angles are congruent, then they have the same measure. So I can write my next statement because of the definition of congruent angles. And there's our proof. Now, something a little bit more subtle was going on here that you probably didn't notice, but I did almost unconsciously. I knew that as I was going through this, that I had to have angle 1 on the left and angle 2 on the right. So as I was working through these statements, I could have put this piece on the right and this piece on the left. Then my last statement would have had to use symmetric property to swap these two sides. But because I knew I had to go there, when I wrote this statement, I wanted to write the angle 1 on the left and the angle 2 on the right so that I would end up having the same orientation at the final result. If you forget to do that, that's no problem. Again, just remembering that you have the symmetric property and you can go ahead and swap those two. All right, let's look at the next proof, and the proof is going to be almost the same, and I'm going to want you to try it on your own first and then start the video back up to look at my proof, and that's going to be the proof of the congruent supplements theorem. And the congruent supplements theorem is very similar, and it simply says if two angles are supplementary to the same or congruent angles, then the two angles are congruent. So rather than angle 1 and angle 3 being complementary, they're now supplementary. So this plus this add up to 180, and this plus this add up to 180. So what we're going to do now is we're going to attempt the proof, and I'm going to want you, before we finish, I'm going to want you to try and work the proof yourself. So pause the video, go ahead and try to work out the proof, and then start it back up again and compare your results. So as I did before, I take a look, I'm trying to prove that angle 1 is congruent to angle 2, and angle 1 is supplementary to angle 3, angle 2 is supplementary to angle 3. So my first step is going to be my given. But what I'm going to say is, because these angles are supplementary, by the definition of supplementary angles, angle 1 plus 3 is 180, angle 2 plus 3 is 180, and I should be able to merge these things together using a transitive property to get me angle 1 equals angle 2, and then I can convert those to congruence by the definition of congruent angles. So that's the general plan for my proof. So let's get started with the given. And now, knowing the definition of supplementary angles, this angle plus this is 180 and this plus this is 180. So hopefully now you look at this statement and you can see the pattern. If A equals B and B equals C, then A equals C. And knowing that I have to have angle 1 on the left here, I'm going to write this on the left and this on the right. So the transitive property told me that if this equals this and this equals this, then this equals this. Now I have this common angle 3 here, and I'm looking to get angle 1 and angle 2 by themselves, so I'm going to subtract out the angle 3 from both sides. And now, because angle 1 equals angle 2, and I have to get to congruence, I know that by the definition of congruent angles, that if their measures are equal, then the angles are congruent. And by the definition of congruent angles, the two angles are congruent, and we've got our proof of the congruent supplements theorem. Now, all these theorems that we've proven so far are now valid to be used to prove other things. And you're going to see that these are going to be very, very valuable as we move forward. But first, we're going to recap a postulate that we looked at in the past. Now, we talked about linear pairs before, and we know that linear pairs are two adjacent angles whose non-common sides form opposite rays, and we now know that this angle is a straight angle, and therefore angle 1 and angle 2 have to add up to 180 degrees, so these are supplementary angles. And that's the linear pair postulate. Linear pairs are supplementary. That's basically what it says. Now, related to this is the vertical angle congruence theorem. We talked about vertical angles before, and we can see that angle 1 and angle 3 are vertical angles, and these two angles are also vertical angles. The theorem says that vertical angles are congruent. So what we're going to do is we're going to walk through the proof of this one. It's a fairly straightforward proof, and it uses some of the theorems that we've talked about before. So the basic plan for the proof, since we have to prove that angle 1 is congruent to angle 3, and we know that 1 and 3 are vertical angles, that means there are two non-adjacent angles whose sides form two pairs of opposite rays. Well, that tells us that angle 1 and angle 2 are a linear pair, and angle 2 and 3 are a linear pair, by the definition of a linear pair. And because linear pairs are supplementary by the linear pair postulate, 2 and 3 are supplementary, and 1 and 2 are supplementary. So here we have a case where angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 2. That means we have two angles, 1 and 3, that are supplementary to the same angle. Well, we just got finished proving the congruent supplements theorem. So if we have two angles that are supplementary to the same angle, then those two angles have to be congruent. So there's the general plan for our proof. So let's go ahead and start out with our given. Now, the fact that these are vertical angles tells us that angle 1 and angle 2 are a linear pair, and 2 and 3 are a linear pair. So by the definition of a linear pair, angle 1 and 2 are a linear pair, and 2 and 3 are a linear pair. Now we know by the linear pair postulate that angle 1 and angle 2 are supplementary, and 2 and 3 are supplementary. Now, since we know that angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 2, then by the congruent supplements theorem, angle 1 must be congruent to angle 3, because both of these angles are supplementary to the same angle. So I said by the congruent supplements theorem, angle 1 is congruent to angle 3. This will wrap up our discussion on the series Reasoning and Proof, and hopefully I'll talk to you in the next series.